I am Reggie, Associate Professor, Department of ECE. Today we are going to see about Unit 4 millimeter wave. On completion of topic, students will be able to understand the basics of millimeter wave. What is a millimeter wave? Most of the radio frequency communication including TV, satellite communication, GPS, Bluetooth utilizing frequency ranging from 300 megahertz to 3 gigahertz. But this band is getting crowded and it's focused on releasing and placing additional spectrum. So the millimeter wave promising for this problem. The spectral band identified by IMT umbrella does not carry such enormous data required for 5G service. But millimeter wave would be a candidate band for 5G mobile communication to carry high data carrying capacity. The main advantages of the millimeter are not much operation at millimeter wave. Spectrum is available at millimeter. Very large block of continuous spectrum. Due to high attenuation in free space, frequency reuse is possible at shorter distance. Spatial resolution is better at millimeter hardware CMOS technology. Advancement in semiconductor technology allow low cost equipment. Small wavelength make possible use of large antenna for adaptive beamforming. Small size of antenna at millimeter facilitate easy integration on chip and installation at suitable location. So a millimeter wave allow larger bandwidth and offer higher data rate and low latency rate that are suitable for high speed internet services. Wireless backlog is another key enabler for 5G millimeter wave small cells. Within frequency, the frequency band of 60 GHz has attracted the researcher to work with large amount of bandwidth are unallocated in this band. Bandwidth are required for communication system or intended data rate of 100 Mbps and above. But another advantage is of 60 GHz band is used as physical property of propagating channel at this frequency that provide natural way of reduction of frequency reuse factor which tend to compact cell size. So the measurement setup is given. The channel sounder based on correlation has been measurement for center frequency of 59 GHz with the bandwidth of 200 MHz. A 90-degree horn antenna is used for transmitting and biconical antenna with elevation of 20 degree is used in the receiver. The measurements are carried out for path loss exponent and RMS decade spread. The result found that path loss exponent was 2 and 2 for outdoor environment and RMS delay is lower than 20 nanosecond. So result also included multipath propagation was bad at parking gauge due to larger dimension smoother surface compared to city street and road tunnel where multipath signal is not significant. This is the thing what they given the measurement setup with respect to transmitter and receiver. So input is sweeping signal generator. From the signal is given to the transmitter via this antenna. The center frequency 59 GHz it is given to the receiving antenna. Through the spectrum analyzer we are measuring the details about in the laptop. So flat omni has the two main component signal generator towards transmitter and spectrum analyzer and receiver. So bidirectional antenna are used as transmitters and omnidirectional antenna and patch directional antenna are as receivers. Measurements were done in order to see the difference in performance because omnidirectional antenna allowed for reflected component. The measurements were conducted for statistics of K factor of Rice distribution and the path loss coefficient for the picocell of the order of nanometer radius at three different locations including indoor and outdoor. So what is the frequency range of millimeter waves typically used in 5G? Millimeter 24 GHz to 100 GHz. Why are millimeter waves are important? They provide high data rate and larger bandwidth. Which frequency is typically used in sub 6 rather than 5 millihertz? So already you know when we are using either we will use greater values which is consider sub rather than millimeter waves. So it will be around 60 gigahertz. Thank you.